One. Two.
Alrighty. Okay.
Number 108. Let's see.
It's a second to last page in the packet.
All right.
That's one game. That one game. That one game.
Okay, Cruz.
That one game. That one game. That one game. That one game. More tiger.
Okay, on 108, this is a sector. So let's see. This in the book is in chapter.
Tiger.
Okay, chapter 11, section 2, I think. Let me double check. Yep. So this is in section 2 of chapter 11. And the theorem for sectors is on 720. So the area of the shaded region round to the nearest tenth. So if you're finding the area, it's related to the area of the whole circle. So the formula you use has the formula for the area of a circle in it as well. It seems like most of the people who have been solving these prefer the proportion form of the formula. Where the area of the sector, which is what you're trying to find, I'm just going to put X because that's what we're trying to find, over the area of the circle, which is pi r squared, equals the degree measure of that sector, the central angle, compared to the degrees of the whole circle. So these are really degrees, but I just left.
Is the percentage way still correct?
Percentage way.
Where you like take 65, divide it by 360 to find what percent of the circle that sector is, and then find the area of the whole circle, and then multiply that by the decimal or divide it by the percent.
I think what you're describing is the other way of writing the formula, where the area of the sector equals 65. Sorry, that's supposed to be 65 over 360 times pi r squared. Yeah, it's the same formula. It's just two different ways to write it. It seems like most of the people I was helping when I was walking around or whatever were using the first way that I wrote, but either way is fine. Yeah. They're both in that theorem on 720 is written both ways. It says the top one or the bottom one, either way.
Okay.
It was just preference. So if you like this way better, we can do it that way. So the area of the sector is your x, 65 over 360 for this circle. And then I should have put, instead of r, go ahead and put the radius in there. Because for this circle, it would be 8. Does that setup make sense?
Yeah.
Okay. So then just be careful in your calculator. As long as you use parentheses, you could do all this, but I would do a times sign between here when you punch it in the calculator to make sure it's not squaring, to make sure it's not multiplying pi times 8 and then squaring that number. Because that would be a different answer. Just the 8 is squared. Does that make sense?
Yeah, that makes sense. That's what I had so far, but I'm just realizing I went through and checked the way I worked it out, and I had plugged in the wrong number. That's why. That looks better. I was like, something. That's why I asked about it, because I was like, something's not right here. So once I did all that, I got 36.303.
That's what I got. And I'm going to double check my key that I have printed out and make sure that's right. Let's see. 108. Yes.
Awesome.
So I got both times, so we're good.
Yeah. Can we work on number 111 as well? Because I found that like on those last two quizzes, that was kind of a type of problem I struggled with, whether it's like finding the apothem or the using trig to find the other sides.
Yeah. Okay, so this is section 11.3 from the book. So if you need to look back over a section, that's where these are. So the area of the polygon. To find the area, the formula, I'm just going to write on top of this. Area equals 1/2 apothem times perimeter.
Mm-hmm.
So you need to know your apothem, you need to know the perimeter. In 111, this is actually, of this type of problem, this is the easiest one you can be given because you know the apothem and you know a side length. You don't have to figure out either of those numbers.
Mm-hmm.
So you can almost go straight to the area formula. Because this 4.3 is your apothem because it goes from the center to the side and it meets it at a right angle. That's the apothem. And then if the side length is 5, how can you find the perimeter?
Multiply 5 by 6.
Mm-hmm. So the perimeter is 30.
Yeah,
right?
30. And
So
then
go ahead.
And then you would multiply that by 2.15.
Okay.
Because that's half of 4.3.
Gotcha. I see what you're doing. Okay.
And then 64.5 not cubic, inches squared or whatever, units squared.
Yes.
Okay. Can we do 112 as well? Because that was actually the specific one that I was having trouble with.
Yes. So 112 is the same question, but you're given different information. This one, you only know the side length, so you can find the perimeter pretty easily, but you need the apothem as well. So let's do the perimeter. Let's start with the easy. What would the perimeter of this shape be?
Well, that's an octagon, so 4 times 8 equals 32.
So we got the 32. To get the apothem, it's all about triangles. So draw a dot in the middle. I'm going to drop down my crooked line. Okay. And then make a triangle. So this is the triangle we want to work with. I like to draw it outside of the thing so I can figure out what lengths I know. All right, the 4, how does it relate to the triangle?
To the triangle, well, the bottom length will end up being 2 because it's half of the apothem to the radius is half of the side length.
Yes. I know what you mean. Yes. All right, so we've got that side. What else can we find out about this triangle?
Well, we have the central angle.
Yes. There you go. You can get the central angle. How do you do that?
Take 360 divided by 8, which is 45, and then divide that by 2 because we have half of the angle between radii.
Very good. You're off to a good start. All right. So I put that 22.5 in the top of my little triangle that I'm working with.
Yeah.
All right. So because that is not a 30, 60, 90 or a 45, 45, 90, and because I only know one side length, I have to do trig.
Mm-hmm.
If it was 30, 60, 90, I could use a shortcut. If I knew, I'm just going to put a number, then I'll erase it. Let's say I knew that this side was 5 or something. Or no, if I knew that was 5, I'd be good to go. If I knew this was 8, let's say I knew the hypotenuse was 8, I could use Pythagorean to figure out my apothem over here.
Mm-hmm.
Okay, so it just always depends on what you know and what you're looking for. So if you know just one side and an angle like this, we have to do trig.
Yeah. So
We're trying to find the apothem. So which one?
It would be cosine. Because it would be adjacent over height. Oh, wait, no. We don't have apothems. So it would be tangent.
Yeah, there you go. Sometimes they'll tell you the radius. If we knew the radius, then you could use cosine to find the side length. Yeah.
That would be cosine.
Or sorry, the apothem. But tangent 22.5 equals what?
0.414213562.
Oh, did you punch that in the calculator? I was setting up my equation. Sorry.
Oh, well, if we're setting up the equation, then it would be equals 2 under the 2 over the x or the apothem.
Yes, I just used an A because it's the apothem, but X is fine. Yes, so it's 2 over the apothem, which means we need to cross multiply. And I don't know what tangent 22.5 times A is. So we're not done. You keep going.
Uh-huh.
This is where some people get lost. Is this where you're losing? Or are you still okay here?
I'm still okay here.
Okay. So tangent 22.5 times A equals 2. Then what?
You would put all of that under 2? No.
Put what under 2?
I was thinking you divide it all by 2. The tangent, you divide the 2 by 2, and then you would divide tangent 22.5 times A, but that would leave nothing in the other side of the equation.
You're trying to get A by itself. So you want the stuff that's with A to go.
Oh, have 2 divided by tangent 22.5.
There you go. Technically, you're dividing on both sides so that this one cancels.
Mm-hmm.
But yeah, tangent.
That number makes more sense. Kept getting like 0.07 or something because I was multiplying it I was dividing it by 2.
Gotcha.
Didn't work.
All right, so it's like 4.83, I guess, if you round to 2.
Yeah.
But remember, don't stop there. I've had a couple people stop there.
Mm-hmm.
That is their answer. Don't do that. I'm sorry, Cruz. Plug it up.
4 times 8, 32. So that's our perimeter. Times 4.8 equals 153 divided by 2, or multiply by 0.5. 76.8.
Let's see. Yes.
Awesome.
Hang on. On my paper, my rounding was different. Let me double check to be sure.
Yeah.
32.
I think I rounded a little early.
Yeah, I was gonna say I got 77.3. What I did is this number, this 4.8 thing,
Mm-hmm.
I left it in the calculator, and
Oh, no.
that
Yeah.
times 32, and then times 0.5. So that I waited till the very last minute to round. I'll help you in just a minute, okay?
0.5. 77.3.
Yes.
Yeah.
So
Yeah.
because calculators will hold that number like that, let it hold it so that you keep your decimal as close as you can.
Yeah, I just input 4.83.
Gotcha.
Okay, that makes sense.
If I could see your work, like what I just wrote right here, if I could see that and I know that you worked through to get that, if your decimal was off like it was the first time you said it, that's fine. That's part of why I don't do multiple choice, because you might get stressed if you're doing multiple choice and you don't see that answer listed. So.
Yeah. Alrighty, well that's the only ones I had trouble with.
Yeah.
So I think I'm
You feeling good about it
overall?
Yeah. Good.
Yeah, overall I'm feeling really good about it.
Yay, good. That's the goal. I know it's a lot of practice, but that's so that y'all feel confident going into it.
Yeah.
You might want to just go back, if these are the ones you're having trouble, look at those sections, the 11.2 and 11.3.
Mm-hmm.
And there's those, the interactive practice things where it's like 2 or 3 questions.
Yeah.
You could do that a couple of times. That might be helpful. Because that immediate feedback.
Yeah, I'll try that. Thank you.
You're welcome.
Have a good one.
You too. Bye-bye.
Bye.
Hey, Bryson, do you have questions?
Yes, I have a few.
Okay.
If I can get to them, actually. Just need to find them.
Okay.
Yeah, numbers 67 and 68 on the packet.
Okay. Let me switch to those. What is it, Cruz? Hang on, bud. All right. Can you see it?
Yes.
All right. So 67, those are interior angles of a polygon. I'm going to find where this is in the book too, so that if you need to go back and look. I want to say it is Virginia 8, but I'm not going to get it. Yes, this is, it starts on page 501 in section 8.1 if you want to go back and look at that section, okay? But the first one is interior angles.
I think.
Turn it down?
Uh-huh.
What do you mean? You can't hear it?
Mhm.
Turn down.
I don't know what you mean, Chris.
No force.
All right, so for interior angles,
Hey.
it tells you there if you were turning there, it's that n minus 2 times 180. Do you remember that?
Yes.
So this shape has 5 sides. So your n would be 5. Because first you need to know what they should all add up to. That's the first step. 5 minus 2 times 180. That's going to tell you the total. So 3 times 180.
There's me.
Yeah. So the total, what'd you get?
Sorry, just
It's all right.
sorry, my calculator just.
That part is just, it would be 3 times 180, right?
Yeah, 540.
There you go, 540. So that's the total. So these problems, they're not going to say, hey, find the total first. So you got to realize that you need a total to start. Then all of these 5 angles together have to add up to that. So you can set up an equation that shows that. So six.
Hey, Mimi.
And that should all equal 540. And then it's a matter of your algebra to solve for x. Does that make sense?
Yeah.
Yeah.
Mom, what's that? A duck.
I don't know.
It's a duck.
A duck?
Yeah.
Okay. What'd you get?
Oh, sorry, I just was trying to take care of something.
Oh, okay.
Um,
A sheep. A sheep. Mom, a sheep.
A sheep?
Uh-huh.
Cool.
Other sheep. Other sheep.
16.
Yes, that's correct. All right, so 68, the way it's different is that these are exterior angles. This is on 503. The theorem for this one is a cow, right? So for exterior angles, there's not a formula to figure out the total. The total is always the same. What is the total for exterior angles?
I'm sorry. What did you say?
When you're doing exterior angles, like on number 68,
Yeah.
the sum of the exterior angles is always the same, no matter how many sides the shape has. And on
Oh,
page,
right, 360, right?
yeah, 360. Okay.
Mhm.
Cruz, 360. So all these together should add up to 360. 13x plus 38 plus 22x plus 1 plus 55. Okay. Be careful with this one. It's a little bit tricky because it's got 13x twice. So don't forget to list it twice when you're adding up all your numbers.
Bob, 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 Bob.
You're silly. Is that what a chicken says?
Yeah.
So when I combine like terms, I got 67x plus 92 equals 360. That sound about right?
I think so.
Are you with me? Or I know you're working on something else there, but are you following this problem okay?
Yeah. Yes.
Okay. So x would equal how much?
That was 4, right? If I worked it out. 4.
That's right.
Thank you.
You're welcome. I need to sign out today, but if you have more,
Yeah, I just wasn't really remembering how to work it out.
gotcha. It's fine. If you have more questions later today, I can check my email. I'm gonna do Math Lab again on Thursday too. So if you have more questions before the exam. All right.
Okay, thank you.
You're welcome. Have a good day, Bryson.
Thank you, you too.
Thank you.
Thanks for letting me eavesdrop on you guys.
No problem. Have a good day.
Thank you. Same to you, too.
Thanks. Bye.